There you go, now it all shows. So once you've checked your answers there, maybe you gotta put it on pause and like check them. All right, I'm gonna zoom in. So we are going to work on the problems that are in the bottom here. And this is the difference of two squares. This is the new stuff that we haven't learned yet. And so I'm going to do the problems with you. The difference of two squares means that it still does factor, but it factors in a special case. So if I'm looking at two numbers that multiply to give me p squared and two numbers that multiply to give me 36, but there is no middle term. So it would look like this, p squared plus 0p minus 36. So I'm looking for two things that multiply to give me p squared, two things that multiply to give me 36, but they add to give me 0. What multiplies to give me 36, negative 36, but adds to give me 0? 6 and negative 6. So it looks like this, p minus 6, p plus 6, and the negative 6 times 6 is negative 36, p times p is p squared, and the inner of negative 6p and the outer of positive 6p adds to give you 0. So when you see the difference, there's a subtraction, of two 1-2 terms, squares or perfect squares, because p squared is a perfect square, p times itself. 36 is a perfect square, 6 times itself. It's got to be a minus in here in order for this to be a negative 6 and a positive 6, and then that drops out the middle term. These two right here, p plus 6 and p minus 6, and again, remember, it doesn't matter which order they're in. These two are called conjugate binomials. Okay, everything's the same except the signs. One is negative, one is positive. So let's look at the next problem here. I have the difference, there's a minus, of two terms, perfect squares. X squared is a perfect square. That's x times x. 25 is a perfect square. That's 5 times 5. And because it's a negative 25, one of them had to be positive, one of them had to be negative, and this inner and this outer will drop out. So a negative 5x and a positive 5x gave us 0, and that's why there's no middle term. Again, these guys are called conjugate binomials because it's exactly the same except one is a plus and one is a minus. So the difference of two squares, if you see two perfect squares and there's a subtraction, it will factor into conjugate binomials. So that's on tonight's homework. Second thing on tonight's homework is perfect square trinomials, but we've already done these. I'm just showing you a different way to write them. So if you're just going to go ahead and factor these, two numbers that multiply to give me 144. First thing that comes to mind is 12 and 12. 12 and 12. Since it's a positive 144 and that's also positive, both of these had to be positive. Let me check the middle. 12r and 12r is 24r. Perfect. But the only difference is these two can be written because perfect square trinomials factor into the same trinomial or binomial twice. You can write it like this. And in the Desmos from last week, you saw that when this happens, when you have the same binomial twice, there's only one x-intercept. All right, so this one, 25, x squared, negative 10. So x squared is x and x. 25 is 5 and 5. And because it's a plus, but that's a minus, both of these were negative. And let me check. Negative 5x, negative 5x, negative 10x. Sweet. So these are the same binomial. I can write it twice, or I can write it as the binomial squared. Okay, enjoy your homework.